So it's been 20 years, believe it or not, 2006, since cloud computing was introduced into the lexicon by Amazon. For those of you in the industry back in the day, you'll remember it was met with everything from optimism and excitement to incredulity and denial. For a while, it seemed like it was going to be the domain of niche players, with many industries declaring themselves off limits to cloud. It'll never happen here. Fast forward to today, and it's almost the opposite sentiment. Cloud has become the de facto destination for most workloads, to the point where many IT grads I meet today have little to no experience with on-premises systems, let alone a process for building their own. But as we saw last year, and will no doubt see again, cloud infrastructure is far from infallible. High-profile outages have revealed an opaque cloud supply chain and exposed hidden single points of failure, which is nightmare fuel for those who've built their businesses on the assumptions of cloud's reliability and availability. And that's before we get to the economics of cloud. For instance, if like me, you spent a few days Vibecoding a new app into existence only to discover that you've created a resource-guzzling monster and a bill to go with it, well, reshoring workloads back to on-premises starts to look attractive even for developers. So what then to do? Welcome to another episode of the AI Forecast, proudly sponsored by Cloudera. I'm your host, Paul Muller. Join me along with leading companies and industry experts as we explore the past, the present, and the future of data and AI in the enterprise. Now, today we're joined by David Linthicum. David is co-author and author of, I think, nearly a dozen books on technology and business, including his most recent, Unlocking the Power of Cloud Governance, AI, Risk Management and Value. He's also an advisor to businesses trying to navigate technology in an objective and pragmatic way. And what I love most about David's work is he's not a cheerleader for any particular technology. He brings a healthy dose of skepticism to the table and uses empirical data to help drive architectural and business decisions. Music to my ears. Welcome to the pod, David.
No, thank you very much. Thanks for your invitation. Yes, I hate everybody, and I'm consistent with that.
Far from it, to be truthful, but I do really appreciate you're almost at great pains to repeat the mantra. It's not a technology decision; it's an architectural and a business decision, and it's a thread that kind of hangs your work together over the last couple of decades.
Yeah, I think that's true. I try to call balls and strikes. I was define it as dare to be fired. Attempted canceled by a lot of companies over the last years, but just trying to figure out what this stuff means and never going along with the narrative and the hype, the ability to kind of look at this stuff and have it prove its worth, and representing enterprises that have to consume this stuff and find value in it. And there's a big difference between what's defined in the hype and what they're finding.
Hey, we're going to jump into talking a bit about cloud and the state of play in cloud and data at the moment. But before we do that, we kick off every episode. We like to be a little contrarian. We bring our lightning round to the front. It's kind of like having dessert before dinner. You ready to play the game?
I'm ready.
All right, first up, what would people who know you best, David, say is your superpower?
Predicting the future of technology.
Heck of a superpower. I'm not even going to try and compete. When did you figure out you had that superpower?
Probably about 20 years ago when I started to write articles and blogs. I was always looking for topics and write about stuff that other people weren't writing about. And so I would look 2-3 years in the future and make some predictions, and many of them came true, and it led into a career and CTO 5 times predicting the future, and did consulting as well, trying to figure out where the technology is going. So I'm good at looking at patterns and seeing what those patterns will likely lead us. So cloud computing, I was early days in that, and everything I'm probably 10 years early. Service-oriented architecture, and now AI. I've been an AI analyst since the 80s. So it's always been, a passion of mine to figure out where the technology is and where it's going to have value. And that's the core thing I want to look at. It's not what I'm interested in, it's what the enterprises are able to be successful with.
Yeah, I love the pragmatism. All right, next up. This is going to be a tricky one for you, I imagine, but what is the most impactful technology of all time, in your opinion? You can go as far back as you want.
Yeah, I got to say generative AI technology. Even though it's recent, it sounds like a cop-out. Cloud computing was okay, but it was just basically rehosting and using other people's, computers at the end of the day with some multi-tenancy, big whoop. Wasn't an innovative differentiator. I think I saw generative AI kind of coming for a long time. I was monitoring the AI research and development space, I watched it and I said, well, if we're able to pull this off, we're going to have something that's going to be fairly handy. It's not revolutionary and it's not the end all, the end of technology, and it's definitely not AGI, but it's something I think that changes the game.
Speaking of AI, what would you like to see AI automate, not for business, but for you personally in your future?
I would like it to be an avatar where I just stand in front of basically talking to a microphone for a living. So have it talk to the microphone for a living and just collect the checks and I'll go fishing.
Send me the binary for that one. I want it too. All right. Last but not least, one thing I've learned, and I kind of repeat to people I coach and mentor in business as well, is that your relationship with data, I think, says a lot about your future success as an executive. What are some of the best practices that you've learned as someone who works with data every day?
Best practices would be understanding the whole of your data. That's something that organizations don't have. I mean, data is kind of the dirty little secret that most enterprises kind of hide away. They use it in silos. They're fairly successful at using it in silos, are good at it, but they have no understanding of what their data is holistically, where the single source of truth is, what the data means, what the ownerships are, and what they mean in context of each other. And now that we have AI coming on, that's forced because you're not going to make AI work for any business purposes unless you have a good understanding and handle on your data. And so you'll have a lot of enterprises running around trying to fix that right now.
I'm going to go off piste for a second because, it's interesting. You've mentioned this. We've had, over 60 guests on the show, and it's been a pretty consistent theme, what you just said then. But I kind of look at, and you've been in tech a long time, cybersecurity and data hygiene as being two things we've been talking about for 40 years. If you're a fan of Eli Goldratt's The Goal, I feel like we just keep fixing one constraint and the constraint moves somewhere else, the problem moves somewhere else. Is this just a Sisyphean task? We're just doomed to be constantly trying to get data hygiene sorted out?
Everybody's been kicking the can down the road for the last 40 years. And I saw it in my career. I've been in this business for 35 years and working with enterprises and the government. And I've watched the data slowly and get worse and worse and worse, even though the technology's gotten better. And I asked myself, why is that the case? Well, normally there's a lot of political, ambitious people in the organizations. They're not looking to coordinate on how the data is going to be, going to work well together. There's lots of little fiefdoms that exist in the companies, and they operate the data in their fiefdoms, and therefore the data basically goes off on 50, 60 different directions within enterprises or in the government. It's like 1,000 different directions, and it just got worse and worse based on the political infrastructure and how people work together. It's more of a psychological issue, I think, than anything else.
Yeah, I agree. It's an organizational construct as well, the politics. Let's jump into it. You've talked a little bit about your background. What are the Cliff Notes versions of your career?
Well, I started out as a developer, did the normal stuff, worked for Mobil Oil and a bunch of big companies, shifted over, started writing books and magazine articles in the early 90s and started working for PC Magazine. And I was a guy doing editor's choice, things like that, and had a lot of fun exposure there. Pivoted that more to enterprise, wrote a book called Enterprise Application Integration, which took off like a rocket, sold like crazy, defined a whole new space. Then I jumped into that space as a CTO because since I created the space, I wanted to make money at it. I was there for probably 8 years when I actually working for 3 different companies, the last one being a cloud company called Grand Central, which did integration as a service, which we started in the 90s. Pivoted there to a couple of CEO roles, which I did mediocre in. But did sell a company and was asked not to work in the technology area for 2 years. So I went off and started a consulting company called Blue Mountain Labs. And what I did is built multi-tenant systems. This is back in 2005, 2006. So I take SaaS systems or software systems, turned them into cloud systems, turned them into SaaS systems. At the time, Salesforce was kind of making some inroads at the time. Sold that. Pivoted into cloud technology partners. We're getting close to the end now. I'm old, so I can go on for days. And helped start that company, rode that for about 5 years. We had a great time, actually the most funnest thing I ever did. Sold it to HPE back in 2016, left there. Next day I got a job as a partner at Deloitte, and I was the chief cloud strategy officer for 10 years. I retired 2 years ago. And now I'm doing the independent stuff where I'm basically able to say anything I want about anybody, love and life.
I love that. I was there at HPE during the Cloud Technology Partners acquisition, and a legendary group of people. So you speak to, I'm guessing, hundreds, if not thousands, of business and tech execs every year. How would you summarize their state of mind when it comes to cloud and the enterprise right now?
They're confused. I think that's a good, if I'm going to use one word, that's it. They are confused in the fact that they felt they were promised some huge benefits and some huge values from cloud when it first started, 10 years ago, 15 years ago, whenever they jumped into it. And they didn't see it. As I write, in my Insiders book, the cost of cloud is about 3 times what they thought it was going to be. And so they're sitting in front of those things now, and they're looking at their workloads, and they're just very expensive to run, and they're taking a lot of cash out of the organization. So they're figuring out what to do. Many of them are repatriating. Many of them are moving to sovereign clouds and micro clouds and those sorts of things. But they're running around in circles trying to figure out what to do. They don't know whether they should stay in cloud. They look at the zeitgeist. Everybody out there is telling everybody to do AI on some of the major hyperscalers, but they can't afford to do that. And so now they're looking for a kind of a heterogeneous best of breed option. And they're extremely confused and in many cases kind of in a panic. I think they're running around doing some experimental projects. We see 95% of the AI projects are failing, and I think it's failing because people are rushing into them and not necessarily understanding the problem they need to solve. There doesn't seem to be a lot of enterprise architecture going on these days, where a lot of it existed 20 years ago. People are more into architecture by chaos. I think that's a good way to describe the Global 2000.
Yeah, and I'm sort of note to self here, we haven't done a thorough podcast on enterprise architecture because it is seen to be a bit of a dry topic for some folks, a little nerdy, but it is, if you go back to people like Adrian Cockcroft and the work that he did at Netflix, for example, a lot of the success and the resilience of that particular system is down to really solid architectural principles. But I think people tend to sort of fast forward through that bit of the movie and just get to the bit where the app gets launched.
Yeah, they do. And I think that, you're absolutely right. Enterprise architecture is not necessarily gaining great interest because not a lot of people are going into it as a profession. They're getting into the micro architectures, cloud architecture, AI architecture, and those are courses I teach. But as far as the enterprise architecture course, I think if I created an enterprise architecture video on LinkedIn Learning, it would probably be the all-time worst seller out there because people aren't interested in this space. And I'm telling people in these organizations, someone has to own the direction, the strategic use of technology, the configuration of everything, what it all means to the business and how all this stuff is going to work and play well together. And like we mentioned, 10, 15 minutes ago, there's a political infrastructure where those guys have a tendency not to be able to get things done. And I think in many cases, they just moved out of the business and eliminated it as a role. And so they may have a CTO, they may have an enterprise architect, but typically they have no power, no capability. They just do PowerPoint presentations, nothing gets done, and things get more complicated. And I'm not sure if I can hit a reset button and jettison our way out of that, but that's the current state of the enterprises. Now, they ask us how things got this bad, and I say there was no formal power, command and control over how you're running your infrastructure. You guys made decisions ad hoc. You were using whatever technology was cool at the time. And that's why they're, like layers of a tree. And now we got a larger, more complex mess that we have to figure out how to get our hands around. And by the way, you want to do AI? We're not going to be able to do AI until we fix that. We have to go back and do some significant surgery on the problems that we already created.
Now, at the risk of being hyperbolic about it, 2025 sort of seemed like the year of the outage as far as cloud was concerned. What's been the reaction in business to last year's headline-grabbing outage?
Quiet panic, I think, is the best way to say it. That's, I could tell the outages were coming because my phone started to blow up. And I hear from the reporters first, and then I hear from my clients second. And they want to know what's going on. How come the cloud's not working? And the reality is they really didn't understand what the dependencies mean. So in other words, I said, the reason you're seeing this, the reason why an Amazon outage is causing everything in your enterprise to fail is because everybody has dependencies on that particular cloud provider. Even if you didn't know that, you're using a software as a service provider in their supply chain, they're leveraging Amazon, Microsoft, or Google. And they're dependent on those things functioning and they becoming a single point of failure. And they always came to me and they would always say, well, isn't the cloud supposed to be resilient to those sorts of things? Yeah, it's supposed to be, and actually be is, two different things. Well, they're pretty good at maintaining an uptime record. I would say the clouds are much more reliable than I thought they would be. And they're going to go down from time to time. And what I think is happening now, I think many of the cloud providers are doing some cost savings. They have the B team in there. In other words, and people who make mistakes. And all of the outages to an outage, you can trace back to some sort of a human error, misconfiguration of DNS servers, things like that. So always something fairly dumb. But those things, and like the AWS outage, that costs many billions of dollars. I'm not sure what the price tag was at the end. I stopped counting at $30 billion, but there's no recourse for it. That basically goes out of your business. And many instances, they lost customers, they lost resources, they lost sales, lost inventory. Everything was out of sync for at least a couple of months after those sorts of things. It was more far-reaching than I think people understood. And the companies were afraid to complain to the public because they were worried about bad press coming in on them. But the reality is it was much more damaging than people thought. And so when that occurred, people are actually starting to question use of cloud. And if they're going to do that, or a single provider doing the majority of your processing, putting all your eggs in one basket, that kind of stuff. I heard those discussions a lot. And I've probably had 20 discussions about resiliency with my enterprise clients for the last 6 months. And
let's talk about that, because resiliency is a funny word, because people, I think, often equate resilience with reliability, and there's a really big difference, isn't there?
There is. I mean, resilience is your ability to not let these disasters, stop your processing and stop your business. And so we had to deal with resiliency, like when I was working for big companies. In other words, what's plan A, plan B, plan C? And the ability to have different failover systems and, things like that. How resilient and fault tolerant is this thing going to be? And the reliability is just basically talking about a component, how well it's going to maintain itself, and if it's going to fall out of place, how are we going to recover from that? Resiliency is your responsibility. Reliability is not, because if it's in a cloud provider, it's their responsibility, but you're going to be impacted. You're going to be paying the bill. There's no credit you're going to get from these cloud providers when they go down.
And at the risk of, not at the risk, going back to our previous conversation, or part of this conversation was resilience is an architectural artifact, not a consequence of a component, really, isn't it? It's how you design your system. It goes back to that enterprise architecture.
It's all architecture, and it's at the application layer, it's at the enterprise layer. You got to build and plan for resiliency. It won't happen automatically. And by the way, it's not contained in the clouds. That's where people were surprised. They thought they were going to be completely resilient from any kind of an issue that they have, and they realized they're fallible like everybody else. So part of building an AI system, part of building an enterprise architecture, part of every kind of an architectural planning is a whole thing of resiliency. And it's as important, if not more important, than security, than governance, and the other things we have to go through. And it has to be operationalized in a way where you can actually prove it with metrics that this thing is not going to stop the business from processing if the worst happens. And you have to basically spend the money and the time to figure that out. If you don't do that, then just count on you're going to have some outages. They're going to cost you $1 billion here and $1 billion there. Because if you don't have resiliency, you're not going to have the ability to recover from these sorts of things. You're going to be overexposed to, system outages and things that occur in the natural state of affairs.
Now, one of the challenges with resilience planning, you'll remember, we all know that every time you add a 9 to your 5 nines or your 6 nines or whatever, you add 10 times the cost. So it's really important to understand the probability of the risk, the nature of the risk, so that you don't over mitigate, right? So you don't basically send the business broke trying to prevent a disaster that's unlikely to happen or could have a minimal impact. How does AI, in your opinion, amplify cloud risk compared to the traditional workloads we've seen?
It's going to be way more complex. There's a lot of moving parts. And so you got to remember, applications were just a database and a memory space of software that's running, and they're communicating one to another, and they can run in the same space and work perfectly fine. When you're dealing with AI, you're dealing with training sides and inference sides and model tuning and all these sorts of things. These things are going to run on heterogeneous environments. They have to, or else they won't have any cycles. You can't push them onto the same, single GPU or even multiple GPU processors. So they have to be distributed by architecture to make them work. And when you do that, that causes a reliability issue, because if any of those things goes down, they stop processing, the network goes down, someone blows the DMS server, it's going to stop functioning. So you're creating more complexity, you're creating more distribution of processes and data, and inference engines and training data. And those things are going to cause problems. You got to remember, if you take a statistics course, you can do the math in terms of the amount of risk that you're adding based on adding additional complexities to this architecture and additional computers, links in a chain. If any of those goes down, the whole thing's going to stop processing. And people don't really kind of understand that. So they assume that everything in this collection of systems is going to be fine. So if we're going to build resiliency into that, we got to think long and hard on how we're going to plan and how we're going to architect it and how we're going to put resiliency into these systems. And reality is that people don't want to pay the bills because it's going to be running in some major dollars, because AI unto itself is about 10 times the amount of money than building a traditional system equivalent. So if I'm doing that, I'm already spending huge amounts of money. Typically, I don't have, and you have to build resiliency in it. And that's what the enterprises are dealing with right now. The complexity is getting them. The complexity where there is really resiliency costs them money to deal with.
The other thing I found, and I mentioned this in the opening, is I've sort of been vibe coding against my better instincts. But hey, it helps me be productive and I get things out of my brain and into production a little faster. But recently, and it's AI related because, of course, I wasn't building an AI app, but the AI was building an app for me. And speaking of architectures, it made some pretty poor architectural choices that meant that about 4 days later, I got this message from my provider going, by the way, you've busted through your monthly limit. You need to send us another $500 or whatever it is. And this is for just an app that was in pilot. And I thought to myself, golly, if this is happening to me, how many other developers in how many enterprises have spun up a little side project in a Vibecoding app that's generated, incredible compute workloads or storage workloads that are resulting in cost overruns? Thoughts?
It's a big problem that few are talking about, but I don't think people have experienced it as much. So in other words, when they're getting into these auto coding things and basically where the AI is generating code, which is actually being run by AI, we're seeing that kind of stuff right now. There's inefficiencies that are going to be part of the process. And so we have to put some sort of a human element and some checks and balances on how this stuff deploys and generates systems. You got to remember, AI is only as smart as we are. In other words, it's a reflection, basically holding a mirror up in terms of best practices, in terms of how we do coding and efficiency and things like that. And what it can't do is really kind of understand the nuances of the problem domain that we're looking to solve. And that's where we run into the issue. Your issue was you're coding by telling the AI system in terms of what your interpretation is and what they need to code. And the thing is, it doesn't understand the nuances that are there. It doesn't understand how to deal with the efficiencies, and you end up spending more money. And so that kind of stuff, the vibe coding stuff, it's fun to think about, but the thing is we have to get some human control over these things. And the more I see these coding systems that go out and, most of my clients are trying them, they're failing because they're not able to get to the efficiency that they need. It's just not able to get to it. So they end up generating inefficient code, costs them too much to run. And certainly if you're paying a cloud bill, things like that, and that won't scale. And so we need to get a little bit more smarter about that.
Now, I want to talk a little bit about accountability as well, because and you've talked about it parenthetically. If we think about on-prem, I'd argue that uptime was 90%, 95% a client problem and 10% the supplier of the hardware and the software, because I guess once it was on-premises, how you ran it was your problem. Cloud, I would argue, flipped the script to a greater degree. Reliability was a vendor problem, and the consumer really had to kind of knit it together. They had a last mile problem. Now, a lot of people are talking about hybrid cloud, but it does seem to be, in some respects, a combination of the best and the worst attributes of both worlds. How do we build clear accountability and observability in what will ultimately be a hybrid world?
If you're building hybrid and multi-cloud solutions, you got to remember you have to basically manage complexity that's part of the solutions. And resiliency is going to be a common control plane that goes through that. And so, people think, well, I'm going to build this thing in a hybrid way where I'm going to be able to fail over to my on-prem systems, if my cloud systems fail, and I can fail over to my cloud systems, my on-prem systems fail, or even fail over to another cloud. Every time you do that, that's perfectly fine and it works, but it's going to cost you money. And I think the ability to kind of understand what those costs are and those resources are and how to manage them becomes the biggest point of contention. So in other words, everybody's for these resilient architectures where we're dealing with heterogeneity and we're putting our eggs in many different baskets, but typically are not able to deal with the cost of the various systems to a company. Every time they see the bill, they want the resiliency, but they're not able to pay the bill. They're willing to take the risk. And I think that kind of stuff really kind of needs to be understood. So multi-cloud is great. It allowed to do the best of breed technology to build more efficient systems, but resiliency and reliability is going to be an issue within those architectures. The complexity unto itself is going to lead to risk, and people have to understand there's greater risk of doing that. Now, if you want to make that completely resilient, you want to architect for that and actives, backups, and different regions that you're running, things like that, get into the complex, nerdy stuff that is about resiliency and resiliency architecture, then that's money. And you're going to have to pay it. I would say you can have resiliency and you can have efficiency, but you can't have both. And so cost efficiency, and people I don't think understand that. They believe resiliency is kind of along for the ride in any kind of an architecture. And the reality is usually they're pretty lucky. The stuff's not going down as much as you think it was. But now we're seeing very complex distributed architectures using multiple vendors, multiple brand name clouds, things like that. And that stuff is well and good, but it's actually making things less reliable, less resilient, and more costly. So that's what we need to prepare for. So we either have to do the architecture to get the resiliency, or we're going to have to deal with outages 3 or 4 times a year. They're going to cost the business billions.
With regards to things like, if you think about catastrophic outages, cost overruns, complex accountabilities, it's not surprising that a lot of companies are thinking about repatriating workloads. What's the state of play there, and what are some of the struggles people have as they're trying to bring some of those workloads back on-prem?
The big thing would be the cost of doing it. There's kind of 2 layers there. Number one, you spent $500,000 on application and moving the stuff into the cloud, and now you're going to have to spend the same amount of money to put it back where you found it. And you got to go to the board of directors and let them know about that journey that you're going to make. So obviously bad decisions were made. So the big thing is someone has to go hand in hand and say, listen, look, I know when moving to the cloud, we thought was going to be more valuable, more reliability, things like that. And it wasn't the case. And so we're going to have to put it back on on-premise systems or a co-location provider or something else, and where we're going to have more control of the hardware. That's going on, but it's normally kind of a secret within many of these organizations. I mean, I was working on a lot of repatriation stuff, over the last 5 years. And to a company, they're not really telling anybody about that. In many cases, it's not even formed up to the board of directors and the CEO. The CIO may know about it, but they're kind of sneaking everything back, to the on-prem system. Typically going to co-location providers and managed service providers are going to have much more efficiency there, but they're reeling from the cost of the cloud. And now that they're looking at the AI workloads, they're trying to make that move even quicker because they can't afford the cloud. Even though the cloud is going to be the easy button for AI, it's the path of least resistance to building these systems. You get a whole ecosystem, that's there ready to go on demand. It's too expensive for the majority of the enterprises out there. So they realize, since the cost of hardware has gone down tremendously at a 45-degree angle in the last 10 years, other than the recent memory prices and processor prices, that's going to be the cheapest way to do it. And so you're talking like buy a 33% in many instances, those things on pricing versus the cloud-based system. So that's attractive, but moving there, they have to get into some other stuff. They're going to have to maintain it themselves, hire someone to do it, lease the equipment, all that kind of stuff. You get into the operational aspects of it, which many organizations kind of fell out of the practice of. They don't have people around who know how to do it. They don't have, to figure out how to run, make equipment leases, all that kind of stuff. And that seems to be the big struggle right now. So if we're going back there, and we're going back there for economies, then we have to put some resources in place to make sure we do that effectively.
To that end, one of the things I've noticed personally as I've been doing, as I say, some development and building in my home lab is there are a lot of tools now that exist, especially even in the open source world, where I can get a lot done on my private cloud, for want of a better term, and have a cloud-like developer experience, a cloud-like experience without having to necessarily put this stuff in the cloud. And in the same way that I suppose Apple took the Unix and open source environment and wrapped it in a lovely GUI to make it all easy to use, do you see vendors potentially wrapping some of these tools and capabilities into a really easy to use orchestrated whole that will shield them from some of these complexities? It seems like an obvious market opportunity.
You mean in the public cloud or in the private cloud, or both?
In the hybrid cloud, I think. That's really the point we're trying to make, is because you talk about the idea it's complex. It's complex largely because of some of the architectural constructs. If someone can knit that together into a coherent whole, the consumer is going to get the benefit of both worlds. They'll be able to have that hybrid experience, but without having to necessarily take on board a lot of that architectural complexity themselves.
Yeah, well, we have two experiments going on right now that have been going on for the last couple of years. And one is AWS Outposts, which is basically it's a hybrid cloud, but you're running a subset of AWS on your own hardware, in your own data center that's connected to a back-end system. And that's kind of the easy button for that. And many people are looking at that as the great solution because they're able to use their hardware so they're not paying a cloud bill. But it's still running on the Amazon ecosystem. So they're using the same tools, the same skills, that they trained everybody for the last 10 years, and they're able to do it on their own equipment. It's not getting the uptake I think people thought it would get, at least the data that I'm seeing. There's Microsoft has a version of that, and I think Google has a version of that, which is basically not getting the uptake. So it's funny, we're giving them the easy environment for the on-prem systems that the big cloud providers are doing. So having a version or a subset of their clouds that are running on their own equipment, we're just not getting a lot of people that are interested in it. Now we are seeing it uptake in the private cloud providers. VMware is having a good run right now, things like that, where they were kind of persona non grata, 5 years ago, because they were in essence engineering projects to get those damn things up and running. I was involved in a bunch of them. So now they're more easier to use. And so they're a complete ecosystem. They come along with, AI private clouds come with everything you need to build these AI systems. Those may be the go-to options for many of the enterprises out there. I don't see the enterprises knitting together their own ecosystems for AI. They need to get something as a service that's completely, out of the box, ready to go. But that kind of stuff needs to run on their own hardware or run on a managed service provider, run on a co-location provider. And I think the private cloud providers are offering, probably something that's going to be a bit more acceptable. So if I'm looking into the future, I see those guys having some good days coming up. And there's a bunch of private cloud providers that are out there selling some pretty good stuff. They're fairly distributed, but people are successful with them. The other thing is we are going to get some of the open source stuff, which basically creates an AI ecosystem. That stuff's pretty good. It's more baked than you think it is. And the ability to have companies depend on those. And of course, is the open source stuff. Many companies don't want to use it for whatever reason, but I think there's fairly good successes there. And so that's where the polished stuff is. When you're looking for these turnkey systems where you're operating on your own equipment, that's where to look right now is private clouds, open source systems, AI ecosystems that you're able to use, and they're baked, they're ready to go, and they work pretty well.
Yeah, it's been my experience as well. A couple of thoughts. Let's not talk about the board because I think that's probably one level too high. But I'm a CIO or senior exec in IT. What are some of the questions that I should be asking my team to inspect to make sure that we're thinking properly about this resilience issue?
I would just basically audit the resilient planning. My recommendation to my clients is hire someone who knows what they're doing and come and audit what you're doing in resiliency. And so, you can use a consultant or whatever, but have some sort of validation that you have the plans in place to make sure this stuff is going to be working. I think because people are missing the boat right now. They're spending money on resiliency and they have maybe a small team of people who are doing it, but they're not doing it successfully. They're not creating an architecture, not creating actionable things that are actually going to make the systems resilient. They're not carrying out the architecture. So the fulfillment of it would be the big thing. I would say, how is this getting fulfilled? What metrics are we using? RPO or whatever, in terms of, monitoring resiliency, how much are we paying? And also, how are the metrics in terms of the money that we're putting into it, in terms of the reliability metrics that are coming back from resiliency operations? So lots of stuff. It has to be good math to make sure that what they're doing is going to have an effect. And I think that's what's missing right now. We don't have a lot of people who are following up with that. And so I noticed after the outages we had in 2025, they swore they were resilient. They swore they had a resiliency architecture. They had 10 people working on it. They had one person in charge of it. And the whole plan that they implemented never was implemented. It was sitting on a book someplace. And of course, it was like, I thought you were going to do it. Oh, we tried to, get Harry's workloads, on it. He wouldn't let us in there. And so, we had to leave it running on Amazon, things like that. And the whole thing went down. That kind of stuff is going on. So they have to take charge of this architecture and give it and make it a first-class citizen, just like security, just like governance, just like compliance. All the other things are going to get you in trouble. This will get you in worse trouble because it stops your business. So what could be worse than that? So it's almost as destructive as a breach, but it's not getting the same degree of visibility.
And again, I'm going to go off piste a little here. Adrian Cockcroft famously championed the idea of chaos monkeys, deliberately breaking the system in production to see how it would fail. And because it will, at some point in time, the old adage, what does this thing do? I don't know, unplug it and let's find out. He took that and made it a real thing and just said, start unplugging stuff metaphorically and literally. Observe the system in stress and ensure that you're building resilience around those stresses. I mean, it sounds somewhat chaotic, hence the name, but I mean, you're really saying businesses need to put their RPOs and their recovery plans to the test.
Absolutely. Absolutely. And so we have to actually do some testing scenarios in terms of testing the resiliency. And I mean, Adrian was absolutely right in his ability to kind of look for vulnerabilities just by messing stuff up, and seeing where they go down. And I think it's the same sort of thing. So they have to ask the question both logically, in other words, looking at a chart and seeing what vulnerabilities you have, but physically, when you actually implement it, what happens if the network goes down? What happens if the DNS server screws up? What happens is connection to the AWS instances going down? How are we able to survive that? Are we able to switch over to something else? Are we going to have to maintain the connection? All that kind of stuff has to be walked through because the worst is going to happen. And I think we're going to see a lot more worse scenarios the next 2 years because we have a shortage of talent of the people who are running these things. I've seen that happen, basically morph into where it is today for the last 10 years. And so we're going to have a lot more people making mistakes. People can make mistakes, but those mistakes are going to cost you many billions of dollars. So you have to figure out how to protect yourself from that.
Look, we've thrown around a lot of terms today, resiliency. We've talked about architectures, and a lot of these concepts can fry people's brains and it can start to seem a little bit like something that someone else needs to work on because it's all too hard. What's a lightweight starter for 6 that people can start working on next week?
What they should start working on next week is figuring out how to, create common operational control planes amongst the various systems. And I think that's something that's low-hanging fruit right now. We have various technologies in there. We're learning to operate and having a single operational layer across many different heterogeneous environments, including the cloud, and putting a plan together and how you're going to carry that out. I was working on something that was at Deloitte called Cloud Complexity Management, or the ability to kind of look at the complexity of multi-cloud and figure out how to normalize the complexity. And I think it's going to be looking at an abstract layer and an operational layer and orchestration layer that's going to run across these environments. So what are those going to be? And that leads into resiliency, because if you're able to do that, you're able to build resiliency in them because you have an orchestration layer. It's able to move processes around, data around, and loads around, as these things fail. And security the same way, and governance the same way. And organizations just kind of seem to be allergic to that because it's overly complex. I mean, the point you just mentioned, in other words, it's hard. So we don't want to do it. Just like fixing our data, that's hard. And you're going to have to run butt heads with everybody in the company. So people don't want to do it. Eventually, we're going to have to figure out these issues. We're not going to have AI scale unless we go through and figure out how we're going to take a holistic approach to all these various problems that we have and stop solving these things in silos. When they think of resiliency, I guarantee you, they talk to me about one silo of systems where there's 10,000 in a company. That's not the way it's done. All these things basically have to put under the same control plane where resiliency is going to be built into a common process that can be shared amongst them. Think like that. Don't think about just siloed-based resiliency. You're not solving problems. You're just actually making more complexity.
Yeah, I do wonder whether the simple answer to the question is that CIOs, and to a greater or lesser extent now business execs, because the two are so inextricably linked, need to have, resilience, the old adage, you get what you inspect, not what you expect. Repeated, periodic, cadence-driven inspections of the resilience of the business, both in plan but also in actuality. It's a simple hack. Put it on your to-do list once every 90 days or 30 days. Go and prod it. Make sure that it's doing what you think it's doing, because the nice thing about not planning is failure comes as a complete surprise.
Yeah, I had a mentor many years ago said it's not real unless it's tested. And I always take that to heart. So in other words, I'm not going to put out a system unless I test it. It doesn't matter if it's an abstract architecture, an AI system, whatever. You got to figure out how it's going to behave from a security point of view, a monitoring and management point of view, resiliency point of view. All that stuff has to be built into it. You're testing the architecture, but you're also testing the mechanisms, in essence, that make up the architecture.
I didn't realize you'd been at CTP. I missed that on your. So I presume you know Jason Newton and some of the folks that I know.
I was like the 12th employee in there, brought in as the executive when I left Blue Mountain Labs, which is a company I sold. And we just had a great time building that company up. It was sad to see it sold, but it was either we had to sell it or, do something else with it, at the time, get another round of funding. And I brought 50 people to Deloitte, but HPE could have done a better job, I think, with that company. But all's well that ends well.
Look, I've worked at HP in the software for business for 20 plus years, and probably the better part of 100 acquisitions. And there were some that were tremendous successes, and others that were abject disasters. And you could never predict which one it was going to be.
I spoke at an HPE conference, and one of the executives came up and apologized to me about it. And he said, "Yeah, we could have done better with that." So it's just the way it goes. But it's one of those things when you start a company, you have some sort of emotional connection to it, and you want to see everything do well. You want to see it maintained and carried on and things like that. So, and I've done that with every company I sold. I think I have, seller's remorse or things like that. But, definitely I was having so much fun when it sold that I was like, oh, now I got to go be a real executive. Okay, here I go.
Well, we'd love to have you back on. It was brilliant talking about this stuff. And I mean it sincerely. I don't think enterprise architecture gets enough airtime. And as we move from building and running to buying and integrating, going back to your EAI topic, integration and architecture becomes the predominant mode of thought, not the occasional mode of thought. But it seems right now that we're still upside down on that. This is my personal point of view.
We are, and I don't see any hope. I don't see any signs that we're getting better at it. Everybody seems to still going in the little, quick movements, things like that. They're not focusing holistically on what's going on. And that's just the way enterprises work. Maybe it's something that can't be fixed, but I definitely see that occur, and I just, okay, well, I guess I'm going to be employed for a long period of time because I make a living unscrewing that stuff up, and these guys are going to keep screwing that stuff up. So maybe I don't want the problem solved, but that's what I do. I have to go show up and, audit projects and fix stuff and redo architectures and redeploy money and, things like that. And okay, it should be doing less work. It should be less stuff be screwed up, but it's a big issue out there. And maybe I'm overly critical of it, but I just don't see anything in sight where it's going to get better. And I think the AI stuff's going to make it worse, just because they're not thinking about using it. They're thinking about small tactical projects, not thinking about fixing their data. They're just thinking about, putting patches and fixes on it. And I understand why they're doing that, because that's the only hope they have of getting something done with the amount of money that they have. But it's not ultimately going to be successful. We're going to have more of these 95% of the AI projects fail.
Yeah, and no doubt about it. And I was very serious about the comment I made. I literally coded up a data-intensive app. I run an astronomical observatory business. It's one of my many hobbies. Yeah. So we host telescopes from around the world. And so I was building a telemetry portal for all of my clients, and I jumped on and Vibecoded something up very quickly. But it was reasonably data-intensive. The Claude decided it needed to be hosted in Vercel, no problems, then put some data into Superbase, no problem. It's making all these architectural decisions for me, and this is the point I'm trying to make. And I'm like, I just want the outcome. I couldn't give a crap where you store it, or at least that's what I thought until it was actually more like a week later. I'm getting these messages from Vercel going, you've blown through your consumption limits. Here's the next bill. And I'm like, what on earth is going on? And it decided to hang on to data that I didn't really need. It was storing multiple copies in different tables. The app was working fine. From a business standpoint, you wouldn't think to yourself, I've got a problem. Architecturally, it was a dog's breakfast. And I spent actually going back to this notion, and I know you like looking into the future, so I like to think I'm just a little data point that might give you some thoughts about what could happen when you scale this up across 10,000, 15,000 developers in a big company. I then had to spend 3 days trying to unscrew the screw up without breaking the application I built. And as you know, it's really easy to break an app once it's working by trying to fix it architecturally. And I just sat there thinking to myself, if this is me and I'm not a professional developer working on this stuff every day, you put 10, 15, 20,000 developers in a company and I made a $500 a month mistake, that's $5 million a month that you could blow through without anyone ever doing anything from the point of view of malfeasance. Like they're not doing anything deliberately nasty, just through a screw up.
It's inefficiency.
Yeah. I just thought to myself, bloody hell, like seriously, like how much agency do you give these tools? And at what point in time do you start baking architectural bad decisions in at scale through automation? It's a staggering potential problem that I don't think anyone's talking about.
Well, I mean, people are getting these large cloud bills just like you have. And that's because they're doing automated, I don't think it's Vibecoding, but they're just using AI tools to generate the majority of the stuff. And it's very inefficient, and it's not using the native tools, even though they say, well, I told it to be efficient. Okay, well, it doesn't know how to be efficient because we haven't taught it how to be efficient because there's no data on efficiency. So it can't understand that. It knows how to build the application. It's going to build the application using the best way it knows how to do it based on the training data, but efficiency is not going to be part of it. And we can program it to be efficient, but there's nothing in there now that's going to cause it to be efficient. What's everybody's doing? They're building these applications. They're getting to the thing that I hate. They say it works. Up it goes. You know, it goes rolling on EC2 and S3 instance, and it's running great. And look in the month, and suddenly it's $100,000 bill when it should be $1. And they're, you know, of course they call me like I'm in charge of the cloud, all clouds. And I'm like, well, did you take a look at the metrics and monitor it and stuff like that? He goes, yeah, it's using a lot of processor time and it's using a lot of memory time and it's using about 3 times the data that we thought it was going to be. Well, there you go. So yeah, but it built it that way. I know, but you're not built. It's not building for efficiency. You got to figure out how to use this in an efficient way. And people are just so enamored with it that it can be done. And I kind of fall in the trap too. That they don't understand, you know, they get to the can we versus should we. And I understand you can, but you shouldn't, because we're not at the point where that thing's going to be economically viable for us. You can run it on your own system and just basically, you know, breach your own environment. If you're paying for a service, you're going to, you know, pay for a lot of money. And these things are going to take a lot of you know, time, energy to fix. So you think with you, now you got an application. In order to fix it, you got to have a knowledge of the system to go in there and start recreating it, which you don't because something else built it. And so that's what my clients are falling into. In other words, how do I fix it? I said,
that's what's blowing my mind is right now it's going to take me more effort to work out what I've done because I didn't do it. Something else has created.
Right.
Yeah. I just, as I say,
no one's talking about it because it's embarrassing, but but everybody's falling into that right now. I have a video out on YouTube I did on my Dave is Not AI channel. I said vibe coding is stupid, and I think I went through that whole thing where we're not seeing the efficiency outcome. I don't think too many people watch the video because it's me going like this, but it turned out to be true.
Look, I mean, I wasn't a fan of it. Gene Kim, who's a very, very good friend, wrote a book recently on the topic and is extolling the virtues of it, which is why I got into it. And as I said, I was astounded at how productive I was. I was able to get stuff out the door. The hidden gotcha is OMFG, the bill you get at the other end, if you're not careful. And I'm sure even if you are careful, it's, as I say, it's terrifying to think that could be happening at scale somewhere right now. David, it's been great having you on. If people are interested in learning more, where can they go?
Oh, just go to my LinkedIn profile. You can find me. There's not too many Dave Linthicums out there, so look me up.
Love it. All right. Well, that's a wrap. David, thanks so much for joining us.
Thank you.
Great. If you've got any questions or comments about today's episode, we'd love to hear from you. Drop a line in the comments section on the podcatcher you're listening to us on, or hit up Cloudera on LinkedIn using the handle @Cloudera with your thoughts. We love to hear from you. As always, you've enjoyed today's episode. Make sure to like, share, and subscribe so you don't miss a drop. Thanks again to Cloudera for hosting another episode of the AI Forecast, and we'll see you all next week.